Look at the night sky. Every point of light is a star, a galaxy, or the dying echo of something long gone. Astronomers estimate there are trillions of galaxies in the observable universe. And yet, the more we uncover, the more questions appear. These are the greatest unsolved mysteries of the cosmos. Puzzles so strange that even the best physics can't yet explain them. In 1950, physicist Enrico Fermi asked a question that still haunts us. Where is everybody? Our galaxy is billions of years old, with hundreds of billions of stars and perhaps 20 billion Earth-like planets. Even if a civilization traveled at just 1% of the speed of light, they could cross the Milky Way in 10 million years, a blink of cosmic time. And yet we see nothing. No signals, no visitors. This contradiction is the Fermi paradox. Maybe life is incredibly rare. Maybe civilizations collapse before they spread. Or perhaps advanced beings exist but choose silence, regarding us the way we regard ants. When astronomers measure galaxies, something doesn't add up. Stars at the edges orbit far too fast, as though pulled by hidden mass. The solution is dark matter, invisible material making up about 85% of every galaxy. We can't see it, but we feel its gravity. And then came the bigger shock. In 1998, scientists discovered that the universe isn't just expanding, it's accelerating. A mysterious force called dark energy pushes galaxies apart faster and faster. Together, dark matter and dark energy make up 95% of the cosmos. The part we understand, stars, planets, life, is just 5%. Beyond Neptune lies the Kuiper Belt, a frozen realm of icy worlds. But at its edge, astronomers noticed something strange. The Kuiper Cliff, where the expected number of objects suddenly drops off. Some models suggest this thinning may be a natural consequence of planetary formation and Neptune's influence, making the cliff less dramatic than it sounds, but it remains an open question. One hypothesis is Planet 9, a hidden giant, perhaps 5 to 10 times the mass of Earth, whose gravity could explain the unusual clustered orbits of distant objects like Sedna. Another more exotic possibility is a primordial black hole, a relic from the Big Bang, no larger than a grapefruit, but with the mass of Earth silently orbiting at the far reaches of the solar system. The search is active. The Subaru telescope in Hawaii continues to scan the skies. And in 2025, Chile's Vera C. Rubin Observatory released its first images. Over the next decade, it will survey the southern sky in unprecedented detail, cataloging millions of solar system objects. If Planet 9 exists, Rubin may be the observatory that finally finds it. But not everyone is convinced. Some researchers argue the orbital clustering might be an illusion, created by observational bias. The tendency to find certain orbits more easily with our current telescopes. Well, if that's true, Planet 9 may be nothing more than a mirage. In 2006, NASA's Arcade experiment detected the space roar, a cosmic radio background 6 times louder than expected. Its source remains a mystery. Even spacecraft near Earth act oddly. During gravity assist maneuvers, some gain or lose speed in ways we can't yet explain. This is the flyby anomaly. And then there's Tabby's star, flickering unpredictably as though something enormous passes in front of it. Dust is one explanation, but some scientists have wondered if it could be the shadow of an advanced megastructure. Most stars obey the laws of physics, but some don't. The pulsar M82X2 shines 100 times brighter in X-rays than theory allows, breaking the so-called Eddington limit. Even our sun is puzzling. Its outer atmosphere, the corona, is millions of degrees hotter than its surface, a violation of thermodynamics. NASA's Parker Solar Probe is diving into the corona right now, searching for answers. And what about the universe's very first stars? The elusive population 3 stars, massive short-lived giants of pure hydrogen and helium. They should have existed, but no one has ever seen one. According to Big Bang models, the early universe should have produced 3 times more lithium-7 than we observe today. This lithium problem has puzzled cosmologists for decades. Meanwhile, the light from distant stars carries hundreds of unexplained absorption features known as diffuse interstellar bands. Chemists think they may come from exotic carbon molecules, but no definitive answer has been found. Galaxies shouldn't exist without dark matter. Yet in 2018, astronomers discovered NGC 1052-DF2, a galaxy that appears to have almost none. Other galaxies, known as ultra-diffuse galaxies, seem to contain far too much. Both defy our models of cosmic structure. And in the center of our own galaxy, the Fermi Gamma-Ray Telescope detects a mysterious glow. One idea is that it's caused by dark matter particles colliding and annihilating. Another possibility is a population of spinning neutron stars. Every day, Earth is bombarded by cosmic rays. Most are harmless, but some arrive with unimaginable energy, millions of times higher than anything we can create on Earth, even with the Large Hadron Collider. The Pierre Auger Observatory in Argentina detects these rare events. Some seem to come from distant active galaxies. Others appear to travel farther than physics allows, raising questions about their true origin. The observable universe stretches about 46 billion light-years in every direction. But that's just the part we can see. Beyond our horizon, does the universe continue forever? If it's infinite, then physics suggests repeating patterns must exist, including exact copies of Earth and perhaps exact copies of you, living parallel lives in unreachable regions of space. Imagine that. Another you, another Earth, playing out a slightly different history, just beyond the reach of our telescopes. Finally, the most unsettling mysteries challenge the very foundations of physics. The Hubble tension reveals that two precise methods of measuring the universe's expansion disagree. One points to a faster rate, one to a slower. The discrepancy may signal new physics we haven't yet discovered. And then there's the matter-antimatter asymmetry. The Big Bang should have created both equally, but in the end, matter won. That imbalance is the reason we exist, yet no one knows why. From galaxies without dark matter to signals we can't trace, from invisible forces to the silence of alien skies, every mystery is an invitation. Each one pushes the boundaries of what we think we know. The universe is not a finished puzzle, it's an open equation. Every discovery adds more questions than it answers. Dark matter showed us invisible mass-shaping galaxies, but not what it is. Dark energy revealed the expansion of the cosmos accelerating, but not why. The silence of the stars may mean life is rare, or that civilizations operate on scales we cannot comprehend. The first stars, population 3 giants, still elude us. Yet their ashes seeded the carbon, oxygen, and iron in our bodies. And every ultra-high energy cosmic ray that slams into Earth carries more power than our greatest machines, a reminder that nature still outruns us. Every question is a roadmap. Why did matter triumph over antimatter? The answer could reveal why the universe exists at all. Is the cosmos flat, curved, or infinite? The answer could mean there are endless versions of Earth and endless versions of you, scattered across unreachable horizons. The deeper we look, the stranger it becomes. The more physics explains, the more it humbles us. Our universe is 13.8 billion years old, 93 billion light-years wide, and still expanding. Yet everything we know, every planet, every star, every atom in us, comes from just 5% of reality. The other 95% remains unseen, unnamed, unexplained. When you look at the night sky, you're not just seeing stars. You're staring at questions that may outlive us, mysteries future generations will chase. The cosmos is a laboratory. We are its apprentices. Perhaps our descendants will solve these riddles. Perhaps the answers will be stranger than the questions. But one truth is certain: the universe is not finished revealing itself, and neither is our journey to understand it. That's it for today. If you enjoyed this, hit like and subscribe. It helps us keep uncovering the mysteries of science, history, and the universe together. And remember, the strangest secrets are always closer than you think. Stay curious. This is My Split Mind.